Good evening, students. How are you? This is Ankit Joshi. I welcome you all on my platform Engineering Maths Guru. So students, in today's session we are going to deal with the probability distributions, very important parameters, what is called as probability mass function, probability distribution function, that is cumulative distribution function CDF, and probability density function. Yes, so students, we will be covering all these important parameters in upcoming 40 to 45 minutes. Stay tuned for the best of the concept. First of all, you have to respond, is audio and video all fine? Let me know if you face any issues. So students, I believe everything is all fine from my end. Let's proceed. So students, as you can see on the screen, we are focusing for GATE 2025, relevant topics for GATE 2025. What we will learn today, you will definitely get one question out of this in the upcoming GATE exam. So students, engineering maths, of course this is the subject. Topic is probability distribution, mass function, that is probability mass function, density function, that is again probability density function, and distribution function, which means cumulative distribution function, we are going to deal in this particular session. Let's proceed. So students, this is the brief introduction about me. I have been teaching in GATE and ESE domain since many years, and my subjects of interest are engineering maths, signals and system, and analog circuits. Students, yes, I am also from electronics background. So may I know who all are online right now? Just you can show your presence in the comment box if you wish. So students, teaching experience is more than 22 years. Students, I taught and nurtured more than 50,000 students while considering online and offline platforms both. So students, I teach for GATE and ESE, and you would be glad to know that I have been teaching mathematics for JEE mains and advanced since long years as well. So students, after the class you may feel where we will get the PDF. So all my dear students, this is my Telegram group, Ankit Joshi _EMG. EMG stands for Engineering Maths Guru. So this is our Telegram link. You can just join this Telegram channel to verify, to solve various doubts, various questions you have in your mind. So students, just you can be the part of this Telegram group as well, and you will become an official, yes, counterpart in our journey. So students, one small announcement. Already on 6th of November we started one engineering maths batch, a dedicated batch for engineering maths. The name of the batch is Sankalp 2025. This is a dedicated batch for engineering maths. Where this course is going on, कहाँ पे ये course चल रहा है? This course is live on my app Ankit Joshi's Maths Manthan. Ankit Joshi's Maths Manthan. This is the name of the app. You can get the download link for the app in the description box, or you can go to the Play Store and just search Ankit Joshi's Maths Manthan. Download the app. After downloading the app, you can just go to the featured courses or stores. You will get Sankalp 2025 batch there. Rest, some discounts are also on there. I believe by tonight 11:59 PM, रात को 12 बजे से थोड़ी पहले तक, you have the discount of more than 50%. Yes, we can say more than 50% on our course. You can just avail that discount and be the part of Sankalp 2025. And of course you can see the recording of the 3-4 classes already completed. If you face any issues, you can directly connect with me. What are the key highlights of this particular batch? So before that, what is Sankalp 2025? This is a comprehensive course dedicated and designed to master engineering maths for upcoming GATE exam. But when I say GATE exam, this course is self-sufficient for you to target ESE prelims as well. Okay, so I will be the faculty in that batch. Of course, teaching experience, you will definitely feel the experience. Have you gone through the line, experience the experience? Yes. So the course validity is up to 31st March, but the course will be completed by 31st of December. That is the maximum time by which we will be completing the course. So students, stay tuned. The key points of this course are: you will get 90 plus hours of live classes. Daily 2 hours of live class will be there. Sometimes somehow you missed out the class, you can watch the video recording and you can make your short notes as well. Classrooms PDFs are also available on the app itself. After completion of the class, after completion of every class, I myself upload the classroom PDFs there. Chapter wise tests will be there. You will get chapter wise test. Doubt clearing sessions can be arranged on your demand if at all required. So students, let's proceed. Haji, yesterday, in our yesterday's session was named as random variables. So I will just give you a brief gist of yesterday's session. Random variable, if the random variable is a discrete random variable, then the corresponding probability distribution is called as discrete probability distribution. अगर रैंडम वेरिएबल डिस्क्रीट रैंडम वेरिएबल होगा, डिस्क्रीट टाइप का रैंडम वेरिएबल होगा, तो उसके करस्पॉन्डिंग जो प्रोबेबिलिटी डिस्ट्रीब्यूशन होगा वो कहलाएगा डिस्क्रीट प्रोबेबिलिटी डिस्ट्रीब्यूशन. बट इफ द रैंडम वेरिएबल इज अ कंटिन्यूअस रैंडम वेरिएबल, another type of random variable is continuous random variable. So if it is continuous random variable, then the corresponding probability distribution will be continuous probability distribution. Sir, what do you mean by probability distribution? Probability distribution का अर्थ क्या होता है? Yesterday we have gone through the meaning of probability distribution as well. I will just repeat. Determining the probabilities for all possible values of a random variable and then arranging them together is called as probability distribution. किसी random variable की हर possible values के लिए probabilities determine करना और उन्हें एक साथ टेबुलर फॉर्म में या फिर फंक्शनल नोटेशन में रिप्रेजेंट करना, ये होता है प्रोबेबिलिटी डिस्ट्रीब्यूशन. सर, कम अप वंस अगेन. डिटर्मिनेशन ऑफ प्रोबेबिलिटी फॉर ऑल पॉसिबल वैल्यूज ऑफ अ रैंडम वेरिएबल एंड देन अरेंजिंग देम टुगेदर, रिप्रेजेंटिंग देम टुगेदर either in the form of a function or in the form of a table. This representation is called as probability distribution. Okay. Now, depending on the context of the problem, probability का सवाल किस context में है, किस परिप्रेक्ष्य में है, इस आधार पर on this basis the type of random variable will be decided. So random variables can be of two types, discrete and continuous. If you want to have the detailed definition of random variable, then just go through yesterday's session as well. So depending on the context of the problem, the type of random variable will be decided, whether it is discrete or continuous. If our random variable is discrete, then the corresponding probability distribution will be discrete probability distribution. And on the other hand, if the random variable is a continuous random variable, then the corresponding probability distribution will be continuous probability distribution. So what are the various types of discrete probability distribution? So students, there are basically 5 types of discrete probability distribution that you will come across while preparing for GATE or ESE. So what are those 5 types of discrete probability distribution? Are you following? Number 1, general discrete probability distribution. General discrete probability distribution. So this is the very first type where we will be defining and covering all basic parameters that you will deal in probability distribution, okay, for discrete random variable. Second one is binomial distribution. When this binomial distribution will come into picture? In case of Bernoulli's trial, we go for binomial distribution. Now what is Bernoulli's trial? That I will teach in a separate session, okay. So, and when it is non-Bernoulli's trial, you go for hypergeometric distribution, okay. There is one special case of probability distribution called as negative binomial distribution, and for this negative binomial distribution a special case is geometric distribution, that is also in your syllabus. And the last but not the least is the Poisson's distribution. When For Bernoulli's trial, you generally go for binomial distribution, but there is a limitation. Even if you are having a Bernoulli's trial, sometimes binomial distribution does not converge, does not finds good. Then you have to go for Poisson's distribution. So what is that threshold criteria? I will not be telling it right now. I will be telling in a separate session because it consumes time. Before going to that advanced concept, you must learn the basics. That's why today's session is placed here. Okay. So general discrete probability distribution, as I discussed. Binomial distribution is the second one. Hypergeometric, of course, the third one. Fourth one is the geometric, and fifth one is the Poisson's distribution. So this is the gist of, this is the list and gist of discrete probability distribution. Now, continuous probability distribution. In case of continuous probability distribution, the random variable involved is a continuous random variable. Okay. So the very first type of probability distribution that you will come across here is general continuous probability distribution. General continuous probability distribution. Okay, sir. In this general continuous probability distribution, what we will do? We will come across terms like probability density function, PDF. Then you will also learn the mathematical expectation, variance and standard deviation for continuous random variable. And yes, the related similar parameters you will get to know here. Then comes uniform and exponential. Yes. So uniform distribution and exponential distribution are special types but simple ones. You should not worry about these at this moment. I will arrange a separate class combining these two. Then comes normal distribution. In case of discrete, we were talking about Bernoulli's trial. For Bernoulli's trial, the first thought is binomial distribution. For Bernoulli's trial, when binomial distribution fails, we go for Poisson's distribution. And when Poisson's distribution fails, that can be approximated using normal distribution. But normal distribution involves tedious integration calculations. So to make the process easier, we introduced one more, that is standard normal distribution. So these are the 10 types of distribution, 5 discrete type के और 5 continuous type के. So 5 are the discrete probability distribution and the rest 5 are the continuous probability distribution. So this is the list of probability distribution that you will learn in case of probability preparing for GATE or ESE or similar exams like ISRO and HPCL and all that. So are you all following? Let's proceed. Now parameters associated with a probability distribution. किसी भी probability distribution से संबंधित important parameters कौन से होंगे? So students, probability mass function. Please remember, mind my words, that if capital X is a discrete random variable, then the probability function is referred as probability mass function. जब capital X discrete random variable होगा, तब probability function का नाम हो जाएगा probability mass function. You cannot use or you must not use this terminology for continuous random variables. Okay. For continuous random variable, okay, when capital X is a continuous random variable, then the corresponding probability function is called as probability density function. Okay, yeah. So there is much difference between the two types of functions. They look similar, but there is much difference between the two, and that you will learn in today's class itself. Chaliye. So probability mass function, this term is used when capital X is discrete random variable. Probability density function, this terminology will be used when capital X is continuous random variable. Now there is one term called as distribution function or probability distribution function. Listen carefully, distribution function or probability distribution function or it is called by one another name, that is cumulative distribution function, in short CDF. So cumulative distribution function is common for both discrete and continuous. So all my dear students, when I say probability mass function, this probability mass function is abbreviated as PMF. PMF. Probability density function is abbreviated as PDF, and cumulative distribution function is abbreviated as CDF. So बच्चा लोग, this is our today's agenda. आज की क्लास में हमें ये कवर करना है, ठीक है. Apart from this, you will come across mathematical expectation. Mathematical expectation means average or mean. So in case of statistics, you calculate average or mean. That mean is equivalent to this mathematical expectation, but this mathematical expectation can be approached with the help of probability theory. Then comes variance and standard deviation. So bachcha log, these are the three statistical parameters: mathematical expectation, variance and standard deviation, that we are targeting, that we are achieving with the help of probabilistic theory. Moment and moment generating function. This topic is not relevant for the common branches: mechanical, civil, CS, EC, electrical, instrumentation, but this particular topic is useful for data science. Mode and median. Mode and median, these are another statistical parameters which can be targeted, which can be calculated, which can be achieved with the help of probabilistic theory. So we have basically three measures of central tendency. One is the mean. Mean is nothing but mathematical expectation. Then we have mode and median. So there are three measures of central tendency of a distribution that we will be covering here. Then we have measures to calculate dispersion. So variance and standard deviation are the measures to calculate dispersion. Of course, this moment and moment generating function are the measures to calculate central tendency, no, sorry, not central tendency, dispersion. There are two more concepts, there are two more parameters which we can use for the calculation of dispersion. One is the coefficient of skewness and another is the coefficient of kurtosis. Coefficient of skewness and coefficient of kurtosis, but I believe they may not be the part of GATE syllabus. So general discrete probability distribution. Probability mass function. Okay, what we have to cover in this general discrete probability distribution is being listed here. Probability mass function, properties of probability mass function, CDF, that is distribution function, calculation of CDF from PMF, distribution function in functional notation. All these topics will be covered here. Chaliye. So let's start our today's agenda and let's start our first concept. I will have a bit of water. See, here the heading is probability mass function. I will explain and then allow you to read all these points. See here. Probability distribution or probability function or probability mass function. In short, PMF. These are the names for the same quantity, and that same quantity is called as, is denoted as f of x. Mind my words, the random variable involved here is a discrete random variable. I will write here, capital X is a discrete random variable. So what is the notation for probability distribution or probability function or probability mass function? There is one common notation, that is f of x. But what is the definition? अरे भाई definition क्या है? So f of x is probability at a given point. At a given point. What is that given point? That given point is a value of x, value of random variable. So students, this probability mass function is nothing but probability at a given value of x, at a given value of random variable. So f of x is probability at a given value of random variable. Is that clear? Okay. So if you are having a probability distribution like this, here we are having the values of x, and just below this the corresponding probabilities. Let us say the values of x are 0, 1, 2, and corresponding probabilities are 1 by 4, 1 by 2 and 1 by 4. Yesterday we have seen one example and I just copied the same probability distribution in today's class as well. Now students, if someone asks you what is the value of f of x at x equal to 0, so f of 0 is nothing but probability at x equal to 0. अरे भाई f of x क्या है? उसी x की value के लिए probability. So f of 0 means probability for x equal to 0. For x equal to 0, probability is 1 by 4. Similarly, f of 1 is 1 by 2. Similarly, f of 2 is 1 by 4. All right. So I want to rewrite the same distribution. Here we have x, and we know that f of x is nothing but equal to p of x. So the values of x are 0, 1 and 2, 1 by 4, 1 by 2, and of course 1 by 4. All right. F of x is nothing but p of x. Now I want to discuss some properties of probability mass function. बच्चा लोग, this probability mass function is probability mass function क्या है? f of x is equal to probability, and if something is representing probability, so it will not be a negative value. So probability mass function is never a negative value, it is always a positive value, and the sum of all possible probabilities can never exceed 1. तो सारी probability values का sum हमेशा 1 होता है. So f of x is always greater than or equal to 0, and summation for all values of x for f of x, it means sum of all possible values of f of x is equal to 1, is equal to 1. So these are the two properties of probability mass function. Now I can represent the same in other way also. See, we know that f of x is equal to p of x, f of x p of x के बराबर है. So instead of writing f of x in properties, I can write p of x also. So p of x must be greater than equal to 0, and summation for all values of x for p of x. What does it mean? Sum of all the possible probabilities, and that will be equal to 1. Okay. Students, I request all of you to subscribe this channel if you have not done so. And moreover, I would like to request, share the link of this particular session in all your contacts to all the needy students. They will be definitely benefited. So these are the properties of probability mass function. Okay, sir. Now let us go through these points. I just said that I will allow you to read these points. Probability mass function can be defined as probability at a given point. Already discussed? Yes. Probability mass function is denoted and defined as, yes, this is the notation, f of x is equal to p of x equal to x, and x is nothing but a discrete random variable. Now, what are the other names? Probability mass function is also known by the name probability function or simply the probability distribution. So, already we have discussed these many points. Is that okay? Now comes the cumulative distribution function. Cumulative distribution function. Okay. Chali. I'll first explain the meaning of cumulative distribution function and then allow you to go through those points. See. Distribution function. Another name is probability distribution function. And another name is cumulative distribution function. Okay. Yes, sir. So, this distribution function is denoted by capital F of x, and these are the various names by which we can call a distribution function. Yes? Just a moment. Check. Now, what is the definition for this distribution function? So, distribution function is, see, probability mass function is probability at a given point. Probability mass function, the earlier one, क्या है वो? Probability at a given point, and distribution function is probabilities up to a given point. Probabilities up to a given point. This is probabilities up to a given point. So, mathematically how will you represent this? Simple. Capital F of x is probability for x less than equal to x. Okay. Now, see this example. This is the distribution we already considered. One by 4, 1 by 2, just a moment. The values of x are 0, 1, 2. So 1 by 4, 1 by 2 and 1 by 4. Yes. Now, for example, if I want to calculate capital F of 1, what does it mean? It means probability for x less than equal to 1. Now, in this table, you have to find those values of x which satisfies this inequality. Okay. So, value of x less than or equal to 1 means 0 and 1. So, for 0 the probability is 1 by 4, comma stands for plus 1, plus, and 1 stands for, see, for 1 the probability is 1 by 2. So, 1 by 4 plus 1 by 2 is 3 by 4. Suppose we are calculating capital F of 2. So probability for x less than equal to 2. Probability for x less than equal to 2 means in this inequality which values will be covered? 0, 1 and 2. So probability for x equal to 0 plus probability for x equal to 1 and then plus probability for x equal to 2. So all these probabilities need to be added. And when you add all these probabilities, what you will get? You will get 1. Arey bhaiya, 1 by 4 plus 1 by 2 plus 1 by 4, you will get 1. Now, are you following my point? I am calculating probability distribution, that is CDF, capital F of x. This is probability for x less than equal to x. Now, if I calculate f of 0, what does it mean? It is probability for x less than equal to 0. Haji. When I say x less than equal to 0, satisfying this inequality, there is only one value, that is 0. And for x equal to 0, the corresponding probability is 1 by 4. Okay. So, students, we will draw a table in which values of x are 0, 1, 2, and here I will mark capital F of x values. For 0, I got the value 1 by 4. For 1, we got the value 3 by 4, and for 2, we got the value 1. Okay. So this is how we can calculate CDF. So this is nothing but cumulative distribution function, and this P of x is nothing but F of x, which is probability mass function. So from PMF we can calculate CDF by using this concept. Now students, determination of CDF from PMF in tabular form. So quickly in tabular form itself, how can we calculate capital F of x? See, we have done all these calculations to find capital F of x. Quickly in some few steps, how can you do it? How can you achieve it? See, this is P of x, that is nothing but F of x. Ye kya hai? This is F of x, that is PMF, probability mass function. Now, in single step, I will be writing the probability distribution function here. Dekho kaise. Probability distribution function is capital F of x. Come on. Drop this 1 by 4 here, and then again lift it to the next value. Add this with this, 1 by 4 plus 1 by 2. 1 by 4 plus 1 by 2 is 3 by 4. Drop it here. Again lift this to the next value. Add these two. 3 by 4 plus 1 by 4 is 1. Drop it here. This is how we can calculate the probability distribution function. We can calculate the CDF directly in tabular form. See, for 3, 4 values of x, either you calculate by applying the entire procedure like this, or you can directly do the tabular calculation. It will make no difference. But suppose x is having 10 values, then doing this process is cumbersome, difficult, lengthy. So this process is an easier one. Okay. Yes, I hope. So our agenda for this session is probability mass function, probability distribution function, that is CDF. So I think 2 we have covered. Few more concepts regarding this. For the probability distribution given below, find distribution function in functional notation. See, here we have calculated distribution function, that is CDF, cumulative distribution function, in tabular form. This is in tabular form. This is capital F of x in tabular form. Now we will be calculating capital F of x in functional notation. Okay. So how you are going to achieve this? Very simple. First I will be drawing a number line. सबसे पहले हम एक number line draw करेंगे. This number line is of course from minus infinity to plus infinity. Now on this number line, you have to mark the values of x 0, 1 and 2. Now as soon as you mark these values, as soon as you mark these values 0, 1, 2 on the number line, what you are getting? You are getting intervals. So distribution function capital F of x will be defined in these intervals. Okay, sir. So the very first interval is minus infinity to 0. So x lying between minus infinity to 0. The next interval is 0 to 1. Then next interval is 1 to 2. And last interval is 2 to infinity. Now I will just include the lower limits. Lower limits are included here. So 2 is included. Just a moment. This is not 2 to 2. This is 2 to infinity. Now lower limits are included. Sir, no, don't include minus infinity, because we can't include minus infinity or infinity. We cannot include minus infinity and infinity. If we can include minus infinity, it means we can equate to minus infinity. If you can equate to minus infinity, it will not be in minus infinity. अगर हम माइनस इन्फिनिटी और इन्फिनिटी की बराबरी कर लें तो फिर वो इन्फिनिटी कैसे हुए? वो तो पहुंचने लायक हो गए ना, दे आर रीचेबल. So if they are not reachable, that's why they are anant, they are infinite or minus infinite, and that's why we are not including these values. Now see here, in the very first interval, distribution function is always 0, and in the last interval distribution function should be 1. Now how to calculate the remaining values? Now see here, in this interval 0 to 1, only 0 is inclusive, 1 is not inclusive. 0 is inclusive, 0 included है, तो 0 पर probability की value है 1/4. So we will write 1/4 over here. We will add the previous value here, and 0 plus 1/4 is nothing but 1/4. Now in the next interval 1 to 2, only 1 is included, 2 is not included, 2 included नहीं है. So in at x equal to 1, what is probability? At x equal to 1, probability is 1/2. We will write the previous value here, that is 1/4. So 1/4 plus 1/2 is nothing but 3/4. In the last interval 2 to infinity, only 2 is included. At 2, what is the probability? 1/4. 1/4. So 1/4. I will add the previous result, that is 3/4. So 3/4 plus 1/4 is nothing but 1. So this is how, using functional notation, we can represent distribution function. Now, when we talk about continuous random variable, if capital X is continuous random variable, then corresponding distribution will be called as continuous probability distribution. And in case of continuous probability distribution, the very first parameter is probability density function. I will allow you to read all these points. Huh? Now see here, I am writing here probability function or probability distribution or simply density function or simply probability density function. So this probability density function itself is called as PDF. So all these names, the notation for all these names is f of x. Now what is f of x? F of x is probability density. F of x, I must tell, see, in case of discrete random variable, f of x was probability mass function. So f of x was directly equal to the probability, but here f of x is not the probability. F of x is not any probability. Why? Because capital X is continuous random variable. Capital X is a continuous random variable, okay? So f of x is not any probability. Instead, f of x is probability density. Instead, f of x is probability density. Remember, f of x is not probability, f of x is probability density. Therefore, integration of probability density function will give us probability. Very simple. Under the limits a to b. F of x is not representing any probability. Integration of f of x will be probability. Understood? That is the logic. Since probability is equal to integration, it means probability will be equal to some area under the curve. Suppose this is probability density function, this is our random variable x, and let us say this is the graph for probability density function, and here we have one value of x is a, another value of x is b. So students, if I shade the area, bounded between this curve x axis and these two lines a and b, then I will get this one. So this area is nothing but equal to this integration, and this integration is equal to probability. So this probability is nothing but area under the curve. When capital X is a continuous random variable, then probability for x lying between a to b will be equal to integration a to b f of x dx, and bacha log this will be equal to area under probability density function curve between the said values. Between said values means x equal to a and x equal to b. Okay, so this area is representing the probability for x lying between a to b. Understood? I hope you got the concept. Come on, fast respond. Just go through this concept. चलिए let's proceed. Now listen here. Since probability is equal to area, है ना, and in order to have area you must have an interval. In order to have an area you must have an interval. At a single value of x you cannot have any area. So area under the curve at a single point is 0, and that's why probability will be 0 for single variable. So when capital X is a continuous random variable, then probability for a single value of x will be 0. It means contribution of these boundary values a and b, contribution of these boundary values a and b to this area is 0. So even if you include a and b, area will remain same, that is probability will remain same. So the concept is probability for x lying between a to b is equal to probability for x lying between a and b, both are included. This time I am not including a but including b, and you can include a and you can leave b. So all these four will give you the same result. ये सभी आपको same result देते हैं, and that is equal to integration from a to b f of x dx. So students, in previous GATE exams directly they asked a question on this concept and as well as on this concept, previous year GATE question. Okay, yes, just have a look over this. चलिए let's proceed. See, if capital X is a continuous random variable, then probability density function is denoted by f of x. Already we discussed this one, just giving you a chance to read this. Probability density function f of x is also known as probability function or probability distribution or density function. In case of continuous random variable, f of x is not the probability but it is probability density. Already discussed these many points. When x is a continuous random variable, then probability at a given point, at a single point, is 0. Just now we discussed this one. If x is a continuous random variable, then probability for x lying between x equal to a and x equal to b is given as an integration a to b f of x dx. And this is the idea. Already we discussed that this is area under the curve. In case of continuous random variable, probability is nothing but area under the curve. Already discussed. When x is a continuous random variable, then all these are equal. Already we discussed this one here. So I guess we need to solve one example. Properties of f of x already discussed. Not discussed? I will discuss here. See, f of x is probability density function. Since it is probability density, it can never be negative. It will be greater than or equal to 0. And number 2, integration. Yes, capital X is continuous random variable. So no summation, it will be integration. So integration of f of x dx, that will be 1. Just have a look over this. Just give me 1 minute. See this example. Just go through this. If x is a continuous random variable with this density function, you need to find out the constant c, the probability is mentioned here. Okay. So all my dear students, see this capital X is a continuous random variable. Therefore, this f of x is probability density function. If capital X is discrete random variable, then f of x will be mass function, probability mass function. Now see here, PDF. So first of all, we will work out for C. Okay. So how to calculate? See here. I will draw a number line. कहाँ से कहाँ तक? माइनस इन्फिनिटी से इन्फिनिटी तक. माइनस इन्फिनिटी से इन्फिनिटी तक हम एक नंबर लाइन बनाएंगे. Now on this number line, we will mark the break points 0, 1 and 2. 0, 1 and 2 are the break points, transition points, जहाँ पर function definition change हो रहा है. Okay. Now in the interval 0 to 1, it is cx square. In the interval 1 to 2, it is cx. In the interval 2 to infinity, it is 0. I guess it should be out otherwise. यहाँ पर 2 to infinity नहीं चाहिए, it should be otherwise. Just a moment. So students, how is your preparation going on for upcoming GATE exam? Now listen here. Since f of x is PDF, f of x क्या है? Probability density function है. तो it must satisfy the properties of PDF. What is the property of PDF? माइनस इन्फिनिटी टू इन्फिनिटी, इस इंटरवल में f of x यानी कि PDF का इंटीग्रेशन 1 होना चाहिए. वेरी गुड. सो माइनस इन्फिनिटी टू इन्फिनिटी कैन बी रीच्ड in 4 steps. Minus infinity to 0, 0 to 1, 1 to 2 and 2 to infinity. Okay. Minus infinity to 0, then 0 to 1, then 1 to 2 and then 2 to infinity. और इन सब का सम हो जाएगा 1. माइनस इन्फिनिटी से 0 के इंटरवल में फंक्शन का वैल्यू है 0. 0 से 1 में फंक्शन है cx स्क्वायर. 1 से 2 में PDF की वैल्यू है cx और 2 से इन्फिनिटी में PDF का वैल्यू है 0. सो ऑल माय डियर स्टूडेंट्स, इंटीग्रेशन ऑफ 0 इज 0. सो फर्स्ट एंड लास्ट इंटीग्रेशंस विल बी ऑफ नो वर्थ. c को यहाँ से बाहर करेंगे, x स्क्वायर का इंटीग्रेशन लिखेंगे. x स्क्वायर का इंटीग्रेशन होगा x क्यूब बाई 3. Limits are 0 to 1. फिर cx में c को बाहर करेंगे, x का इंटीग्रेशन लिखेंगे. वन to 2 and right hand side is equal to 1. Now concentrate. c by 3 is out. 1 cube minus 0, so 1 minus 0 हो जाएगा ये. Then c by 2 is out. In place of x we put 2, so 2 square is 4 minus 1 square which is 1 equal to 1. So c by 3 plus 3c by 2 equal to 1. 6 is the LCM, 2 is cross multiplied, 3 is cross multiplied in the second term. So this is 11c by 6 equal to 1. So what about c? C will be 6 by 11. So the very first answer, so this is the common, very common variety in GATE exam which they ask. C का वैल्यू, तो C का वैल्यू कितना आया दोस्तों? C is 6/11. Now probability for x lying between 1/2 to 3/2. Probability for x lying between 1/2 to 3/2. चलिए देखते हैं. Probability for x lying between 1/2 to 3/2. बाउंड्री वैल्यूज इंक्लूड हो या ना हो, रिजल्ट सेम ही आएगा, है ना. नो, दिस विल बी इक्वल टू इंटीग्रेशन फ्रॉम 1/2 to 3/2 f of x dx. Now I will draw the number line. यहाँ पर जीरो है, फर्स्ट एंड लास्ट में जीरो दे रखा है, यहाँ पर सी एक्स स्क्वायर और यहाँ पर सी एक्स है. नाउ 1/2 से 3/2 का इंटरवल है, तो जब आप 1/2 से 3/2 जाएंगे तो बीच में ब्रेक पॉइंट है 1. सो 1/2 से 1, 1/2 से 1 एक इंटरवल होगा, 1/2 से 1 एक इंटरवल होगा और 1 से 3/2 दूसरा इंटरवल होगा. सो 1/2 से 1 में फंक्शन का वैल्यू आप लेंगे सी एक्स स्क्वायर, और 1 से 3/2 में आप लेंगे सी एक्स. सी बार x³/3, लिमिट्स आ गई 1/2 से 1, फिर सी बार x का इंटीग्रेशन x²/2, तो c/3 बाहर, x की जगह 1, 1 का क्यूब 1 ही रहेगा, फिर 1/2 का क्यूब हो जाएगा 1/8. x की प्लेस पर आएगा 3/2, तो ये हो जाएगा 9/4 -1. ठीक है. अब देखिए 8 - 1 ये हो गया 7/8, तो 7c/8 3 = 24. कैलकुलेशन तो कर लेंगे. 9 - 4 5, 5/4 आ रहा है, तो 5c/4 2 = 8, 5c/8, 5c/8. नाउ 24 इज द एलसीएम, 7c + 15c हो जाएगा ये. सो दिस विल बिकम 23c/24 एंड c इज 6/11. सॉल्व करने पर आपको मिलेगा 23/44. ये कैसे हो गया? समथिंग रॉन्ग, क्या कर दिया अपन ने? 1/2 से 3/2 ना. सी x³/3, सी x²/2, x³ 1 - 1/8. ओके, c/2 इज आउट. 9/4 -1, 8 - 1 7c, 7c + 15c इज 22c. 15 और 7 हो जाएगा 22, सो 22c/24. सो 22/24 6/11. सो इसको सॉल्व करने पर आएगा 1/2. One by two is the probability. All right. So for this question, second part we obtained the answer is 1/2. Just go through the third part as well. Third part is probability for x less than equal to 3/2. Students, mind it, either these points are inclusive or not non-inclusive. this result will remain same because boundary value's contribution towards the probability is negligible, nothing. So probability for x greater than equal to 1 by 2. Probability for x greater than equal to 1 by 2. Okay. So it means 1 by 2 is the lower limit. We can write this way also. 1 by 2 less than equal to x. Now what is the upper limit? Upper limit is not mentioned. So let us assume it as infinite. Now I will draw a number line here. Number line कहाँ से कहाँ तक? Minus infinity to plus infinity. Now the breakpoints are 0, 1 and 2. These breakpoints are already mentioned in the problem itself. Now we are calculating the probability from 1 by 2 to infinity. हमें probability calculate करना है 1 by 2 से infinite तक. So 1 by 2 will be a point here. So from here we will reach up to this point. So the value of the function in the first and last interval is given as 0, and value of the probability function or PDF is given as Cx square between 0 to 1 and Cx in the interval 1 to 2. See, Cx square in 0 to 1 and Cx between 1 to 2. Now we have to integrate from 1 by 2 to infinity. So we have to split this integration. Just a moment, see. Probability from A to B is nothing but integration from A to B. किसका integration? Density function का, that is f of x का. Okay. So students, we will split this now. So 1 by 2 to 1 is the first part and 1 to 2 is the second part, and of course 2 to infinity is the third part. Now in the interval 1 by 2 to 1, 1 by 2 से 1 तक, यहाँ से यहाँ तक, what is the value of the function? It is Cx square. From 1 to 2, this point to this point, value of the function is Cx. 2 to infinity, function is 0. 0 का integration तो 0 होगा, cancel हो गया sir. C is taken out here. X square integration is x cube by 3. Limits are 1 by 2 to 1. C is out. Integration of x is x square by 2. Limits are from 1 to 2. This third part is 0. Now C by 3 is out. In place of x I am putting 1. Then x is 1 by 2 in the lower limit. So 1 by 2 cube is 1 by 8 plus C by 2. X is 2, so 2 square is 4. Lower limit minus, then 1 square is 1. So 8 minus 1 is 7 C by 24. 4 minus 1 is 3 C by 2. Now 24 is the LCM here. 7C as it is. 12 3s are 36C. उम्मीद करते हैं समझ में आता होगा. 36 plus 7 is 43 C upon 24. So 43 by 24, what is C? C is nothing but 6 by 11. So 43 upon 44 will be the answer for this probability. Probability for x greater than equal to 1 by 2. 43 by 44. And student, by the similar process, if you solve the last one, you will get the answer as 23 by 44, and this you can do as homework. I am proceeding for the next concept. Can I have your response quickly, fast? फटाफट आप respond कर दीजिए. Is everything all fine regarding the concept? I request all of you to subscribe this channel if you have not done it so. चलिए लेट्स प्रोसीड देन. Now distribution function. Okay, so distribution function already discussed in case of discrete. Definition stands same here, but what is the logic? Distribution function is nothing but capital F of x, and this is probabilities up to a given point. Distribution function means CDF. Distribution function matlab cumulative distribution function, CDF. So distribution function is CDF. It is probabilities up to a given point. Probabilities up to a given point. All right. So f of x is probability for x less than equal to x. Now students concentrate कीजिए. तो capital F of x is capital X is bounded on the upper side by small x, this value, and lower limit is not mentioned, so we will take it as minus infinite. Already we know that probability for x lying between a to b, either you include boundary values or not, the result is integration a to b. और integration किसका करना है? Density function का, small f of x का. So again this is distribution function which is written as a probability. So this probability will be the integration of density function. Interval is from minus infinity to small x. So distribution function capital F of x, that is CDF, this is probabilities up to x, probability for x less than equal to x, and we can calculate this using this concept. Following? Are you following? Yes sir. See it. Oh, already being written there. So this is the concept for CDF, but calculation of CDF is much more tedious, requires much more skill. So calculation of cumulative distribution function for continuous random variable, more than concept, it requires skill. See here, if capital X is a continuous random variable with density function, already the density function is given, and yes, this is the same density function that we discussed earlier. Find the distribution function. We need to find the distribution function, and already for this function we have calculated the value of C, which was 6 by 11. Okay. Okay. So let us calculate the distribution function. Okay sir, okay sir, okay sir. I will be first drawing a number line from minus infinity to plus infinity. On this number line, we will be marking the breakpoints. On this number line, we will be marking the breakpoints. What are the breakpoints? 0, 1, and of course 2. In the first and the last interval, density function is 0. In this interval, it is given as Cx square. In this interval 1 to 2, it is given as Cx. So in these many intervals, distribution function will be defined. Capital F of x, that is CDF, will be defined. The very first interval is from minus infinity to 0. The second interval is from 0 to 1. Third interval is from 1 to 2. See the number line. Fourth interval is from 2 to infinity. Lower limits are inclusive. As I already told you, you cannot include minus infinity and plus infinity. No. Always remember, in the very first interval, cumulative distribution function is always 0. And in the last interval, it is always 1. So we need not be calculating these two values. Okay. You can verify the value 1, but we will be calculating distribution function for these two intervals. Okay. 0 to 1. 0 to 1 देखते हैं. in this interval. Draw a number line from minus infinity to current interval's upper limit. Current interval's upper limit is 1. So we will be drawing a number line from minus infinity to current interval's upper limit. Now compare this interval minus infinity to 1 with the original number line. Minus infinity से 1 को यहाँ compare करा. Any other break point you find between minus infinity to 1? क्या कोई break point दिखाई दे रहा है minus infinity से 1 में? हाँ दिख रहा है. What is that point? 0. So I will be marking this 0 here. अब हम यहाँ पर f of x की values mark करेंगे, which is 0 and cx square. Now what to do? You have to repeat these breakpoints on the upper side of this number line. Minus infinity, 0. No, don't write 1 here. This is the highest upper limit. So we will just write it as x. इसको आप लिख देंगे x. Now recall the formula for distribution function. What is that formula? Minus infinity to infinity f of x dx. So distribution function capital F of x is minus infinity to x small f of x dx. Okay. Now minus infinity से लेकर x तक इंटीग्रेट करना है. So minus infinity to 0 and 0 to x. Now listen carefully. In minus infinity to 0, small f of x is 0, and from 0 to x it is cx square. Calculate this and finally put the value of c as 6 by 11. So this is 0. C is out. Integration of x square is x cube by 3. Limits are from 1 to x, not 1 to x, 0 to x. Understood? Integration perform कर दीजिए. C by 3. In place of x we are putting x, so we will get x cube. Lower limit is 0. Value of c is 6 by 11, so you will get 2 by 11 x cube. So this is distribution function in the interval 0 to 1, 2 by 11 x cube. Now we will be calculating distribution function in the interval 1 to 2. 1 से 2 में distribution function calculate करेंगे. Now I will be drawing a number line from minus infinity to current interval's upper limit. Now breakpoints here are 0 and 1. The value of density function is 0, cx square and cx. Now we will mark these points on the upper side, minus infinity, 0, 1, and this uppermost limit will be replaced by x. Distribution function capital F of x का format क्या होता है? It is minus infinity to x integration of density function from the limit minus infinity to x. Then 0 to 1. Then 1 to x. I hope you got the process to calculate distribution function. Now we will be calculating this integration. This part is 0. Cx square is out. C is out. Integration of x square is x cube by 3. Limits are from 0 to 1. यहाँ पर c को बाहर करेंगे, c will be out. Integration of x is x square by 2. Limits are from 1 to x. Now in place of x we are putting 1, lower limit is 0. In place of x we are putting x only, so no change, x square. Lower limit is 1, so 1 square will be 1. C is taken out, so 1 by 3 plus x square minus 1 by 2. Now C is nothing but 6 by 11. यहाँ पर हमने 6 LCM लिया, so 2 here and 3 here. हाँ, 3x square minus 3 and plus 2 is minus 1 upon 11. So this is our distribution function. Distribution function for this interval 1 to 2. Three x square minus 1 upon 11. So this is how we calculated the distribution function. So students, I have taught you probability mass function, probability density function, and distribution function calculation for both discrete and continuous. So I think we are done with the session. If some 5 minutes concept are more there. See, always remember that you can calculate probability for x lying between a to b. How? By integration of density function in this interval a to b. There is another way. If you have distribution function with you, then you can calculate the same using distribution function also. देखो, अगर density function given होगा तो आप उसका integration कर लेंगे. अगर distribution function given होगा तो आप उस distribution function capital F में upper limit रखेंगे minus capital F में lower limit रखेंगे. So this is how we can calculate the probability with the help of distribution function. Now, if x is a continuous random variable जिसका CDF दे रखा है, you have to calculate this probability. So probability, देखो CDF given है और अभी हमने एक रूल देखा, probability calculate करने का एक फॉर्मेट देखा. क्या फॉर्मेट था? Probability is equal to distribution function at upper limit minus distribution function at lower limit. Okay. तो probability for 1 by 2 less than equal to x less than equal to 3 by 2. ये क्या होगा? अपर लिमिट 3 by 2 है, तो डिस्ट्रीब्यूशन फंक्शन का वैल्यू निकालेंगे 3 by 2 पर माइनस डिस्ट्रीब्यूशन फंक्शन का वैल्यू 1 by 2 पर. तो 3 by 2 यहाँ पर आएगा, मतलब इसमें आप रखेंगे 3 by 2. ओके, तो इसमें आप 3 by 2 रख दीजिए, तो 3 इंटू 3 by 2 का स्क्वायर माइनस 1 अपॉन 11, बीच में माइनस, फिर 1 by 2 कहाँ पर आएगा? 1 by 2 इस इंटरवल में आएगा, मतलब यहाँ पर आप 1 by 2 रखेंगे, तो 2 by 11 1 by 2 का क्यूब. तो देखिए, ये पहले पार्ट को मैं सॉल्व कर रहा हूँ इसको, तो 9 3 27, 27 by 4, तो सॉल्व करने पर आएगा 27 माइनस 4 यानी कि 23 अपॉन 44, ये पहले पार्ट का आंसर। इसको देखो आप इसको सॉल्व करेंगे तो 1/44 आ जाएगा। फर्दर सॉल्व करने पर आपको 1/2 मिल जाएगा। सो प्रोबेबिलिटी फॉर दिस x lying between 1/2 to 3/2 is nothing but 1/2. Probability for x greater than equal to 1/2. Probability for x greater than equal to 1/2. इसका अर्थ क्या है? इसका अर्थ है कि 1/2 लेस देन इक्वल टू x है और अपर बाउंड पता नहीं तो इन्फिनिटी रखना है। अपर बाउंड इन्फिनिटी है तो f ऑफ इन्फिनिटी माइनस लोअर बाउंड इज 1/2। सो इन्फिनिटी कहां पर आता है बच्चों? इन्फिनिटी इज लास्ट इंटरवल में आ रहा है। इन्फिनिटी पर डिस्ट्रीब्यूशन फंक्शन का वैल्यू है 1 और 1/2, ये देखो 1/2 रखने पर कितना आया था? 1/44। सो 1 माइनस 1/44 इज नथिंग बट 43/44। ऑलरेडी हम ये सारे कैलकुलेशंस डेंसिटी फंक्शन का यूज करके कर चुके हैं। नाउ वी आर डूइंग द सेम कैलकुलेशन यूजिंग डिस्ट्रीब्यूशन फंक्शन। नाउ प्रोबेबिलिटी फॉर x लेस देन इक्वल टू 3/2। सो लोअर बाउंड इज नॉट मेंशन, तो आप माइनस इन्फिनिटी ले लीजिए। से कहां तक जाना है? 3/2 तक जाना है। सो f ऑफ 3/2 माइनस f ऑफ माइनस इन्फिनिटी। सो 3/2 पर कैपिटल f ऑफ x का वैल्यू है 23/44। डिस्ट्रीब्यूशन फंक्शन का वैल्यू 3/2 पर 23/44 और माइनस इन्फिनिटी तो सबसे पहला पॉइंट है, वहां पर 0 आएगा तो 23/44। सो दिस इज हाउ वी कैन कैलकुलेट डिस्ट्रीब्यूशन फंक्शन एट डिफरेंट पॉइंट्स। दिस इज द रिलेशन। डेंसिटी फंक्शन का इंटीग्रेशन करेंगे तो डिस्ट्रीब्यूशन फंक्शन आएगा और डिस्ट्रीब्यूशन फंक्शन का डिफरेंशिएशन करेंगे तो डेंसिटी फंक्शन आएगा। ठीक है, हाँ जी। स्मॉल f ऑफ x का इंटीग्रेशन करेंगे तो कैपिटल f ऑफ x। स्मॉल f ऑफ x यहाँ पर क्या है? PDF, प्रोबेबिलिटी डेंसिटी फंक्शन। इसका इंटीग्रेशन करोगे तो क्या आएगा? CDF आ जाएगा, क्यूमुलेटिव डिस्ट्रीब्यूशन फंक्शन। और CDF का डिफरेंशिएशन करने पर, उल्टी प्रोसेस है ना, CDF का डिफरेंशिएशन करने पर आपको प्रोबेबिलिटी डेंसिटी फंक्शन मिल जाएगा। ऑलराइट, मज़ा आया? चैनल जरूर सब्सक्राइब करें। और स्टूडेंट्स, संकल्प 2025 हमारा बैच है जो हमारी ऐप अंकित जोशी मैथ्स मंथन पर लाइव है। 6 नवंबर को शुरू हुआ है। द कोर्स इज ऑलरेडी स्टार्टेड ऑन 6th of November on our app Ankit Joshi's Maths Manthan. The link to download our app is already given in the description box of the same session, or else you can just go to the Google Play Store, search Ankit Joshi Maths Manthan. You will get our app from there. Download it and go to stores. Just click on the stores and then you will see Sankalp 2025 batch. A lot of discount is being there. The price for the course is 3,600 and till tonight the course is available maybe less than 2,000. So just you can avail this discount. We will solve these questions in our next session. What is that next session? Next session is about some problem solving based on PDF, PMF and CDF, and of course I will be discussing mathematical expectation in the next session. Thank you. So this is our Telegram group. Students, to join this Telegram group, and yes, this is the download link, but this is not clickable here on the screen. You can just copy this link from the description box. This is our customer support number 95527 95557 95527 95557. चलिए, thank you so much students. Love you all. Take care. Stay happy. Stay safe. जय हिंद, जय भारत, जय महाराष्ट्र.